All right, so we are doing solutions to linear systems using matrices, okay? We're gonna focus on matrices. We're gonna talk about by hand, but we're also gonna just focus on using technology as our tool. So we're gonna represent systems of linear equations with matrices, learn row echelon form, perform Gaussian elimination, learn reduced row echelon form, perform Gauss-Jordan elimination, solve systems of linear equations with technology optional. So me personally, because most of you have decided you're not going to careers in mathematics, we're going to kind of minimize our expectations. We're going to probably not do this. And what used to be optional is where we're going to actually focus at. Does that make sense? Now, if you are a person who plans on making math and physics your career, let me know and we can go on a little more in depth independently. But as a class as a whole, I'm going to focus on this, okay? The main thing that we're going to talk about here is an augmented matrix, okay? When you have an augmented matrix, what you're doing is you're taking equations and you're putting them in terms of a matrix. So here you actually had three equations in the form of AX plus BY plus CZ equaled a constant, right? And what you did is you took out the coefficients and constants and you created an augmented matrix, okay? So the first row represents your first equation in standard form. Second row is your second equation in standard form. And your third row is your third equation in standard form, listing out only the coefficients and the constants, okay? So basically, when people create a matrix, they want to eliminate the letters, the extra distraction that may have created some problems for people. Okay, when you're talking about a matrix, the dimensions are row column. I think of RC Cola. Do y'all remember or know of RC Cola, the drink? RC Cola, that's how I remember row column, row by column. RC Cola, row by column, the off-brand cola. Okay. It's not, it's the Dr. Pepper version of everything else. So, but that's how you remember. So for example, here, there are 2 rows, 4 columns. So we say that this is a 2x4 matrix. Yes. All right. What we're going to do is practice transforming these two into augmented matrices, and then stating the dimensions. Cool. So first up, we have a 2-variable linear system, and of 3x minus 2y equals 4, and negative 7x plus 2y equals 1. First, you want to make sure that they're in standard form, and they are in standard form. Standard form for 2 variables is ax plus by equals c. Are these in standard form? Yes. Can I create a matrix from that? Yes. So for your matrix, again, you're listing out your coefficients and your constants. The number one thing I need y'all to remember is the sign goes with it. If it's positive, it goes with it. If it's a minus, that means it's plus a negative. That negative goes with that number, okay? A lot of times you drop your negative because you just think, oh, that's subtraction. Subtraction means plus a negative, okay? So my augmented matrix here is going to be 3, -2, and 4, -7, 2, and 1. Okay, that bracket got real weird. Okay. And so now I created what are the dimensions here? A 2x3. Okay, so 2-variable systems are going to always create 2x3s. Does that make sense? Yes. Yes. All right, cool. Next, here we have an example of a 3-variable system. 3-variable system means that you're in the form of ax plus by plus cz equals d. Okay, notice that we're missing a variable, right? When you are missing a variable, you're going to put a 0 in its place. So we're missing x here. So this is going to be 0x. Okay, every variable has to be represented. Every constant has to, well, constants will automatically be there, but every variable has to be represented when you're creating the matrix. Okay, so when I create this matrix, again, first equation, we have 2, 3, -1, 0. Another big mistake is people forget Casper the Friendly One. Okay, don't forget Casper the Friendly One. 3, 0, 3, Casper the Friendly One, 1, -1. Because Casper is a ghost and 1's invisible. Again, we have -1, 2, Casper, 1, -4. Okay, So we took our 3 variable and we turned it into a matrix. And what are the dimensions of this matrix? A 3 by 4. Okay. How do you feel about converting between systems and matrices so far? Easy conversion? Doable? Cool. All right. Can you go the other way? If I give you a matrix, can you write it as a system? Yes. So remembering, it's always your X, your Y, your Z, your constant. Your X, your Y, your Z, your constant. Okay, so for the first one here, we have X minus 2Y plus 4Z equals 7. Then we have 2X plus 5Z equals -2. Then we have 3X minus 6Y plus 8Z equals -1. My braces are gorgeous, I know. All right, I want you to take a moment and do B, and then we will check. All right, so here we should have started off with X plus 3Y plus 6Z equals 1. Okay, and mathematicians, we're not lazy, but we like to be efficient. So if I can write less characters than necessary, I write less characters. So notice how even though it says 1, do I put the 1? No, because it's not necessary. All right, so now we have Y minus 2Z equals 3. And then we're left with Z equals -9. And that's my system. It's actually a fairly nice system to solve, right? Because it tells you your Z, then you just go up, plug it in and find your Y. Now you have your Y and your Z, you just go up, and you plug it in and solve for your X. Pretty nice. All right, we're going to talk about this type of matrix in a moment. All right, so here it says this is a linear equation represented by an augmented matrix. Can I solve this? And the answer is yes, I could. I could totally solve this. And that's because I know the value of my Z. And because I know the value of my Z, I then can also solve for my Y. So we're going to go through and we're going to solve this system really quick just so that we can see the levels of substitution. Is that cool? All right. So starting off here, I'm going to use my first equation, my first row, my third row of my matrix to write an equation. And that equation is, I know that Z equals -5. Agree? Okay, because I know that, I can go to my second row of my matrix and solve for Y. That's because here, I know that Y equals, no, I'm sorry, I skipped a step. Y, I'm gonna write it out and then I'll write with Y. Y minus 4Z equals 30. So I know that Y equals 30 plus 4Z. Does that make sense? So I can easily solve for Y. So Y equals 30 plus 4 times, and what is the value of Z? -5. So what does Y equal? Y equals 10. Yes? So now I can keep going and I can go up like, okay, well, this one says that X equals, keep wanting to jump to that step, and I got to remember, be the teacher and write it all out. X plus 2Y plus 1Z equals 16. So I know that X equals 16 minus 2Y minus Z. And I know the value of Y and Z, so I can solve for X. So this leads me to X equals 16 minus 2 times 10 minus -5. And what does that give me? We all agree? So just making sure, remember we go left to right when we're adding and subtracting. This is negative 20, so we have 16. Minus 20 is negative 4. A negative times a negative is a positive, and negative 4 plus 5 is 1. So now we now know the value of each one. So our solution is 1, 10, negative 5. Okay. Do you see how we use that augmented matrix to work our way through solving the system? Yes. Now, this is made possible because of how this is set up. The setup here allowed us to have, I call it tic-tac-toe, 3 ones in a row. Okay. When this happens, when I get these 3 ones in a row and these 3 zeros, it's already eliminated some of the work for me, right? That is your goal for when you are using a matrix to solve by hand, is to get it down to this format. Okay. You want to get it down to tic-tac-toe, 3 ones in a row, so that you can solve from here. Okay. Do you guys want to practice one, or do you feel fairly confident in doing it? Feel good? Feel good with getting it down to this format? All right, now the question is, how do I get it to this format? Okay, this format is called row echelon form. Okay, how can I get it down to row echelon form? And we do that by manipulating the rows, by creating new rules, by multiplying and combining to create new rows. Okay, but our goal is to get it down to row echelon form. And once we're in row echelon form, we then can go from there. Okay. We're going to click here. I thought I had embedded it, but apparently I did not. It may have been the one. So there's some videos that don't allow you to embed.
Okay, here I'm going to use Gaussian elimination to solve a system of equations. We've got x plus y minus z equals 9, y plus 3z equals 3, negative x minus 2z equals 2.
Okay, we're going to watch most of it.
So the first thing I'm going to do is write down my augmented matrix. So from the first row, our coefficients are positive 1, negative 1. My constant is 9. Our second row, we have 0x, we have 1y, we have 3z, and our constant is 3. And from our last row, we have negative 1x, we have 0y, negative 2z, and our constant is positive 2. So what we're going to do is, our goal in this case is, we want to write this in row echelon form. So the idea is, we're going to write the matrix so that it's in triangular form, and where the leading coefficient in each row is equal to 1. Okay, so to do this, I look at my first row. I want the first non-zero entry in the first row to be a 1. So in this case, we've got a positive 1 here. And again, the idea is, if you kind of look along the diagonal, forget about the constants. We're going to make the entries below that into zeros. We're going to make the constants all equal to 1. That's what we're shooting for here. Okay. Once we do that, we're going to use some back substitution. So again, my goal eventually is to get zeros here, and I want 1s along the diagonal. That's what we're going for. That'll kind of be step 1 here. Okay, so to get a 0 in the third row, first column, I'm just going to take row 1 and add that to row 3. That's going to replace my row 3.
So notice how he's writing a mapping of what he's doing, right? So I'm saying how I'm manipulating that matrix. So I'm identifying what I'm combining and which one I'm going to substitute it back in with, okay? That's the first thing, is to make sure you identify your change.
I like to use the little arrow to indicate which row is changing. There's tons of arithmetic in these problems, so anything I can do to help myself organized, I always found that helped. So I'm not changing the first row. not changing the second row either. And now I'm going to do my arithmetic. So 1 plus -1 will be 0. That's what we wanted. 1 plus 0 will be 1. -1 plus -2 will be -3. And then 9 plus 2 will be +11.
So that's your new matrix.
Okay, so again, we want ones along the diagonal, again, forgetting about the column with the constants. Well, we do have a 1 in our second row, second column, so that's good. We said we wanted to get zeros everywhere below that diagonal. Okay, everywhere below that diagonal. So I need to change the entry in the third row, second column. I want to make that into a 0 as well. Well, if we just add row 2 and row 3, that's not going to do the trick. But if we multiply the second row by -1, and then add that to our third row, I think that'll do it for us. So let's see here.
So again,
I'm not changing the first row at all.
we're not changing the second row.
Now I'm going to change the third row again by doing the arithmetic. So -1 times 0 plus 0, that's just 0. -1 times 1 will be -1. We add -1 to +1, we'll get to 0, which is exactly what we wanted. -1 times 3 is -3. -3 plus -3 will give us -6. -1 times 3 again will be, well, -3. -3 plus 11 will be +8. And now we've got our third row. All right, we're getting close. The last thing, again, we want to do is we want to make our
Ones.
first non-zero entry in the third row, which is our -6. We want to make that into a +1. Well, what I'm going to do to the third row is simply, you can think, I would divide by -6.
So you're gonna multiply.
We don't really think about division so much. We always talk about multiplying by non-zero constants. So I'm going to multiply the third row by -1/6. And that's going to give me my new third row. So in essence, you're just dividing the third row by -6. Again, not doing anything to the first row. Not doing anything to the second row. -6 divided by -6 would be +1. 8 divided by -6, well, that would be 8 over -6. And we can reduce 8 over 6 into 4/3, again, not forgetting the negative. Okay, so now we've got our.
All right, so now you're reduced row echelon form, right? I mean, you're row echelon, not reduced, row echelon form. And now you're at the point where you can do the backward substitution, right? I now know Z. I can use Z to find Y. Once I find Y and Z, I now can find X, right? That's the goal of that. Now that I understand where you guys are as a class, we're going to talk about how can I let the calculator get me into row echelon form? Does that make sense? Okay. That's the math. That's the algebra behind it. How can the calculator help me get into that format is what we're going to model in here. Is that cool? Okay. How do you feel about the math though? Is it that bad? It's like a giant puzzle with how I've always viewed row echelon. Is what It's not that bad, right? And to me, it's kind of fun. It's kind of like, oh man, all right, what's the next manipulation I can take? What's the next piece to my puzzle? All right. But we're gonna stop right there because I think you see the overall where we were going with it, right? Once you got your three ones in a row, tic-tac-toe, and your 3 zeros, you were good to go. Now, what we're going to talk about here is using the calculator to get us to that backwards format. Is that cool? Okay, so the first thing we're going to do is create our matrix. So creating our matrix here, it's going to be, and I never put the line. I don't know. The line always bothered me. It just seemed like an unnecessary thing for me to write. If you prefer to see with the line, by all means, let me know. So I have 1, 1, -1, and 2. I have -1, 1, 1, and 3. I have 0, 1, 1, and 9. Oh, thank you. I don't know why I wrote -1. Okay, now in my mind, this seems kind of like a doable one to get. My ones are almost, we're there. I just gotta get rid of the zeros, right? So it's not that bad to do, but again, I know it's not our strong suit. Cool. So the first thing you're gonna do is create this and identify your dimensions. My dimensions are gonna always be 3 by 4. All right, so we're now gonna go to our calculator. So I'm gonna pick up my handy dandy calculator. If you like the challenge of eliminating it down to row echelon form, you can do it by hand. I'm gonna reset Sylvie, second plus 712. Okay, to access all things matrix, we're gonna press second x to the -1. So we press second x to the -1 is where we access all things matrix. So what did I press? Second x to the -1. Okay, we're going to edit. So these are all the matrices you can have. Matrix A, B, C, D, E. Notice that they don't have any dimensions. That's because they are blank. They haven't been defined yet. We're going to define them by going over to edit. So we're going to go over to edit. Second, x to the -1. Got it? Now we're going to arrow over to edit and we're going to call this matrix A. So we're going to click on 1 for A. Once I'm there, I'm going to put in my dimensions. My dimensions are 3 by 4. And now I'm going to fill in the matrix. To navigate through the matrix, you type the number, then press enter. Type enter, and it will keep going. So I'm going to press 1, enter, 1, enter, -1, enter, 2, enter, -2, enter, 1, enter, 1, enter, 3, enter, 0, enter, 1, enter, 1, enter, 9. Okay. Nope, she don't want to do it. You stop. What about you? All right, so now that we have our matrix in, we need to return back to our home page. I think you should be fine if we did it. Let me double check. See if it'll let us. Hey, escape, my bad. So we're gonna press second mode, and it takes us back to the home page. So we're exiting out of the matrix because we created it. Now we're gonna re-enter the matrix and we're gonna perform some math. So second matrix. Notice this time that our matrix A is now defined, right? So it's a 3 by 4 that we created. So it's a defined matrix. We're gonna go to math. And it's best to arrow up instead of scrolling all the way down. So I would advise you to press up and you're going to see where it says REF. That stands for row echelon form. REF stands for row echelon form. Okay, so we're going to click on REF. After clicking on REF, we then are going to go back to the matrix and click on our matrix that we created, which is 1. So what we're telling the calculator is, I want you to put this in row echelon form for me so that I can use backward substitution to solve. Does that make sense? So we're going to press enter. And it says, all right, here you go. And it now creates your matrix for you. So we're going to write it out. This is where it becomes important for you to also know your fractions, your friendly fractions, and their equivalent decimals. So my row echelon form, we are now at 1. We have -1/2, -1/2, -1. We have 0, 1, -1/3, and we have 2 1/3. We have 0, 0, 1, and 5. Which one? Which step?
Oh,
Solve it. Okay. So again, to get here, we went back to our second x to the negative 1, went over to math, and we're going to arrow up to A where it says REF, row echelon form. We hit it. And now we're going to click on second x to the negative 1 and click on our matrix that we created. And we hit enter. Now on your calculator, I believe you can make it give it to you in fraction form because your calculator is updated. So if I do it again, I'm going to go to math, arrow up to REF, add my matrix, close parentheses, and on your, for you, if you press math and you see where it says frac, you're going to press 1 before hitting enter, and it should tell you your fractions, just like so. Did it? Yeah? Okay. Now back in my day. Oh. But now that we have updated calculator, it will do that. Okay, so if you struggle with the common fractions or getting the fractions. Yes. So after you do the second, that's the negative 1, and now the arrow up to REF. Yes. All right. How do we feel about letting the calculator get it down to row echelon form? Good. Now, if you don't like it, then you have the ability to manipulate the rows just like we did with our systems, with our elimination method, right? All you're doing is manipulating the rows and creating it until you get down to tic-tac-toe, 3 1s in a row and all zeros. You can do every last one. All right, and then from here, can I now do backward substitution to solve this? Yes, I now know that Z is 5, and because I know that Z is 5, I can solve for Y. So when I'm typing this out, I'm a lazy person once I have a calculator in my hand, I'm not gonna lie. So I now know that Y equals 2 1/3 minus plus 1. I can't even save it. I'm gonna have to type it. Plus 1/3 times Z. And then I know that X equals -1 plus 1/2 times Y plus 1/2 times Z. And once I have that, I can full on do everything from the calculator. I'm going to open up my calculator. So to first solve for my Y, I'm going to do 2 1/3, which is 7/3. So I have 7/3 plus 1/3 times 5. Why? Because I know that Z equals 5. Hit enter, and I get my first value. Y is what? 4. Now I'm going to do X, because now I know the value of Y and Z. So I have -1 plus 0.5 times, what was Y? 4 plus 0.5 times Z, and Z is 5. So now I know X is 3.5. So 4 was my Y. So my solution here is 3.5, 4, 5. Okay. Yeah. How do we feel? It takes practice. It's something, that's what I said. It's imperative that you actually do it with the calculator. Otherwise, you're going to get stuck. Okay. So here is yours to do from beginning to end, and I will be walking around to help you. Cool. All right. If you want to clear your calculator, remember second plus 712. And you're going to start from scratch. Okay. And I will be around to help. Is 5 minutes good? I think. Okay. Okay, so the first thing you had to do was set up the matrix, right? So you should have 2, 2, 1, and 2, -1, -1, 2, and 4, -2, 1, 1, and -1. That got weird, but yes. So when I go to my handy dandy calculadora, good old Sylvie, I'm gonna turn her on. I'm gonna go to my matrix. So again, second, x to the -1. So the first thing I'm gonna do is input the matrix. Second, -1, input the matrix. So I'm gonna hit edit. I have a 3 by 4, and I'm gonna put in my values. Make sure you put every value in its spot. We are human, we make mistakes. So when you're done, just make sure you put them all in. So I have 2, -1, -2, 2, -1, 1, 1, 2, 1, 2, 4, -1. Yes. Then I'm going to hit second mode to leave the matrix. Now I'm going to go to the matrix math. To get to the matrix math, I'm going to hit second. X is -1. Go to math. And I want row echelon form. So I'm going to go to AREF. Going to go back to the matrix window, second x to the -1. I'm going to use my matrix that I created to ensure that I have exact values. I'm going to close it with the parenthesis and use the math to get fractions. Hit enter. So from there, I now have my row echelon form. So I now know that the row echelon form is 1, 1, 1/2, 1, 0, 1, 2/3, 1/3. I have 0, 0, 1, and 2. So from here, I know that z equals 2. Did we get that? The last row tells us our z. So we know z equals 2. Our second row is our y. So we have y plus 2/3 z equals 1/3. Our first row, we have x plus y plus 1/2 z equals 1. And now I can work backwards to solve, right? So I'm going to plug in z here to get the value of y. Then once I plug in that, I get y, and then I'll have y and z to plug in. Did anyone complete? And what we get is our solution. And 2. Good job. Okay. Now, I did want to show you like the 3 special cases on your notes on your thing. The notes, it should be written out on your, what's that place called? Right space. These are all listed. The only thing that's not there is the fraction feature, because back in TI 83, it wasn't reliable. But I do want to mention that what it looks like when you have no solution and when you have a solution. Okay. So if you look right here, this right here, the 3 zeros, this means I have infinite solutions. Do we see that? This right here means I have a solution because I got 3 ones ticked in a row, right? Here, I have infinite solution because what happens? 0, 0, 0, 0, 0. Here, I have no solution because it's anything else but all zeros. Does that make sense? So be mindful when you are solving the problems from there. And that is the gist of 4. Questions, comments, concerns? Let me know.